All right, way back when we used something called the chain rule, which in which we used a U to define a section in a problem that looks complicated. We simplify it by replacing the variable U for the entire binomial, usually complex. And then we performed the basic derivation operation on that, and then we resubstituted it in and came up with our final answer. We're going to do the same thing with integration. This is called pattern recognition. When you see a problem, that a part of the problem is a derivation of the main part of the problem, then this is a valid way of simplifying the process of getting these integrations done. So let's take a look at some examples of this. On page 304, problem number 1 through 6, I believe they have a series of columns. They give you the main function here, and then they ask you to break it down to U and DU. So that's what we're going to do here. The first one was this value here, the integration of 5x squared plus 140 squared times 10x dx. You're asked to integrate that. You're looking at that, holy cow. But you notice though that the 10x is actually a derivation of what's inside the square here, and that makes life a lot simpler here by identifying the u, which is this complex right here, 5x squared plus 1. The derivative of u is the derivative of 5x squared plus 1, which is 10x dx. And so you would put in the first column 5x squared plus 1, second column 10x dx. And what you eventually are going to be doing in the rest of the problems, I'll show very quickly here what's going on. You're going to take, you're going to replace the u for the 5x squared plus 1 here, so u squared, and this whole thing right here represents the derivative of u, so we put that right there. So we just simply perform an integration on this, which is going to be u cubed over 3 plus c. Then you substitute the 5x squared for u into that, and there's your answer problem. Very simple once you make that substitution. So pattern recognition is what this is all about, by using the u's and the du's and looking at some complications involved with du's. We go through this. So let's take a look at another one of these very simple ones. And this time, rather than do this, because this wasn't part of the answer, that was just a demonstration of what you're doing with this in the last half of the assignment, or last 2/3 of the assignment. Now, this is a fairly complicated looking thing here, right? So it's going to be, you're going to have to use the chart for trigonometric functions or integrations to understand what you're looking for here. You got tangent squared x, secant squared x. But if you take a look at the chart, you know that the differentiation of the tangent is secant squared x dx. So if we make u the tangent of x, then the derivation of u is secant squared x dx. And so we're going to be replacing that chunk of that with the du dx, or just du, if you will. All right, so let's take a look at some problems in which we can solve for this. We're going to take the integration at number 7 of this. This is the problem right here. So obviously the u is going to be what's inside this parenthesis here, 1 plus 2x. The du is the derivation of u, which is the derivation with respect to x of 1 plus 2x here, which is 2x. Well, in the problem, we have 2 and dx, and so we'll replace this with du and then derive it. And we get, and actually this is not correct, this is plus c is what I should have there. But you add 1 to this and divide by the new exponent, which is u to the 5th over 5, plus c, and then you replace 1 plus 2x for u, and you get 1 plus 2x quantity to the 5th power over 5, plus your constant. And remember, this is an indefinite integral. You will not have an a and a b, there will not be endpoints, so this is indefinite, so you need to include the c for that. problem number 11. This is the problem they give us for this, x cubed times the quantity x to the fourth plus 3 equals quantity squared times dx. Obviously the u means that's going to be x to the fourth plus 3, so we're going to use that as u squared later on. Then we take the derivation of x to the fourth plus 3, and we get 4x cubed dx. Now here's where the complication begins. We don't have 4x cubed dx, we have just x cubed dx. But we can still work around that by identifying first of all that x cubed dx does not equal du, that du actually equals 4x squared or x cubed dx. So what we want to do is get rid of the 4 in the x cubed dx and leave us x cubed dx and see what part or how many parts of the du we're going to get. So we divide both sides by 4 and we get 1/4 of that du. So now we get into the integration using just the u's. And as you can see, then this is going to be u squared here. And we said that this is equal to 1/4 du. We put that together and we write it like this. And then remember, du is the derivation of u by itself. When you integrate it, becomes 1. So this becomes 1/4 right there. And it's multiplying, and then of course we kick this up from 2 to 3, and that means the denominator has to be the new exponent 3. So you put that in there, multiply that out, and of course there should be a plus c right here, which I constantly forget. Oh, the hilarity. U cubed plus 12 plus c is what we should end up with. Now we go ahead and substitute x to the fourth plus 3, and our answer is this complex. Constantly forgetting. Oh my goodness, where do I come up with this stuff? And where do I come up with, make sure you throw it away. All right, so now we got square roots. Oh no, oh no, oh no. Oh yeah, it's easy. Let's see. Again, t squared plus 2 is going to be your u. The derivation of t squared plus 2 becomes 2t. There is no mxu 2t dt. There is no 2t dt, but we can let's see here. So that means then yeah, I think I must have forgotten to put a t here. Let me look at the problem real quick. Yes, I did. So that wasn't working. There's a t right here in front that I forgot. So this is 2t dt and d dt, t dt. So we go ahead and solve, since du equals 2t, and we get the t by itself, or and that should be dt right here. So t dt will equal to du over 2. So t dt is going to be du over 2, and this becomes then u to the 1/2 power. All right? Now, so we take the derivation of du to the 1/2 power, and we increase that by 1, and putting that new value in the denominator right there. This is du over 2, multiply it by that. And well, actually, we shouldn't have the du there because that is now 1/2 when we take, when you go the other direction with that and you integrate it. So that gives you 1/2, and then the 2 in the denominator and 2 in the numerator cancel out. That leaves you 3 right here. So this gives you u to the 3/2 over 3 plus c. Now we bring in the t squared plus 2 for u, and there it is. And if you remember how to copy a problem down, that gives you a lot more leverage in doing it right. Constantly making mistakes. Oh, and it's indefinite, it will never stop. Jeez. All right, here we go. Number 19, same kind of thing. U minus x squared will be our u. Our du is the derivation of 1 minus x squared, which is negative 2x. Negative 2x dx actually. Put that in there. And that means that x then is going the x is going to be the x dx rather. It's going to be du over negative 2. And so that means then when we write this as u, this is the negative third power, so it's u to the negative third power. X dx we said is du over negative 2. Put du over negative 2. Derive that. We get next higher exponent from negative 3 is negative 2. So we put negative 2 in the denominator. And the derivation of du is 1, so that's negative 1/2. And negative 2 times negative 2 is positive 4. So this gives us u to the negative 2 over 4 plus c. And as we said, we identified u as 1 minus x squared. Plug that in there. And then the 4 has to be included, and we usually put that in front. So this would be your answer right here. Watch the little details of the problem. You can see the mistakes I made. Can get you in trouble because things are not appearing where you expect them to do and you get lost. So make sure you find those dx's where they should be and watch how you derive things. So your answer, or rather your practice problems, are these 6 problems right here. Have fun.